If I ask you what was or what is the most feared or difficult to understand part of mathematics, most of you will answer calculus. I can say this because many of my friends in academia and my teachers think the same. Although there are people who like it most, but those numbers are very few. The reason for this may be that it is mostly application based. Although there is a vast theory of the subject, but main use of calculus is to solve problems. Problems of physics, chemistry, economics, and even mathematics. Students mostly don't have any problem in understanding the theory, but they often struggle in applications. The aim of Calculus and Analytical Geometry series is to help students struggling with Calculus 1 and help teachers who want to make their lectures more interactive and fun. The approach will of course be geometric, and we will try to geometrically interpret as many concepts as possible. So let's start with first video of the series in which we will learn about slopes. Before proceeding, let me just tell you a bit about why I started with slopes. I think slopes play the same role in calculus as primes play in number theory, or in fact positive integers play in number theory. Concept of slopes is the most basic thing you should and you have to study. In this lecture, we will see what slopes of a straight line is, what values it can have, and how slopes of two straight lines are related. Okay, so without any further delay, let's just start learning. The first basic question whose answer we are seeking is what is slope of a line. One thing you should remember is that slope is always defined for a straight line, so you will not be asked to calculate the slope of, let's say, a circle or maybe a parabola. Okay, so this is a line as it is passing through these 2 points. So if I change location of one of the points, the line passing through them will also change, as you can see here. The slope of a line is the ratio of its projection on y-axis and projection on x-axis. What projection on x-axis means is starting from this point, you go along axis of x until you are directly below this point. Same way, the projection along y-axis means going below. Here below means going towards origin until you are directly in front of this point. We will call projection along axis of x run and projection along axis of y rise, and we will call this segment ramp. Now let's see how the values of slope changes for different lines. So right now it's something and now it's something else. See here, the slope is increasing and now it's decreasing because I have kept the run constant and I keep on changing the rise. If I keep the rise constant and I change the run, we'll see the slope will still decrease or increase according to increase or decrease in run. So knowing what slope is, let's just explore what values slope of a line can have and what those values actually mean. This is a line passing through these 2 points. I will change the location of one point and you just keep an eye here. This will tell you how the values of slope is changing. So now it is positive, still positive, and now it is negative. Okay, still negative, and now it's 0. So we see that the slope of a line can be 0, positive, or negative. It can be one more thing. Here it is. It says the slope is undefined. But what does it mean? Let's get back to our first animation to understand the meaning of all kinds of slopes. We saw earlier that slope basically means ratio of rise and run. So as our rise and run changes, here the slope also changes. But we were playing in this area only earlier. Let's just take this point here and now we see that slope is negative. This is happening because now our projection on x-axis is negative as we have to go in negative x direction to see just below this point. Since run is negative now and rise is positive, the ratio of what we call slope is negative. Same way you see here, rise and run both are negative. So the slope is positive, while here the slope becomes negative again. Let's come to other two values, 0 and not defined, and see what actually they mean. You see now it is showing slope to be 0. It is because the rise is 0 now, so no matter how much we change run, the slope is going to be 0 always. We can draw one important conclusion from here. You see that rise being 0 means the line is parallel to x-axis, because to reach other point on the same line from one point, you don't have to move in direction of y-axis. You just keep moving along or parallel to x-axis and you will reach that point. And we saw that rise being 0 implies that slope is 0. So we can conclude that x-axis or any line which is parallel to x-axis has a slope of 0. Now let's talk about undefined slope. One thing I want to tell you here is infinite and undefined are two different things, and so many people confuse between these two. Infinite is a mathematical entity. It has a mathematical meaning, while undefined does not mean anything. It simply can be anything. I will discuss more about undefined in some other video, but right now let's get back to the track. So this says the slope of this line is undefined. We can proceed the same way we did in case of zero slope. In case of this line, you see that the run is 0. So no matter how much the rise is, the denominator of the ratio is always going to be undefined. Another conclusion. Yes, the slope of y-axis and line parallel to it is undefined. Think about it. We have discussed about what slope of a line is, what values it can have, and now it's time to see how slopes of two lines are related. Since we have not discussed how two lines can be related because we do not yet know about equation of straight lines, so we will discuss only for the most common pairs, that is, parallel lines and perpendicular lines. Before starting to explore how slope of parallel and perpendicular lines are related, just keep in mind that coincident lines have same slope. So if I have two lines that if I place one over other and they are indistinguishable, then they will have same slope. This fact is quite obvious and there is nothing to prove. Okay, so here are two parallel straight lines, which we will call line 1 and line 2. Here is an option to tilt the lines and change their orientation, and using this we can increase and decrease the distance between them. But one thing that stays the same is that these two lines are parallel. Now to see what is the slope of line 1, we draw this little ramp run triangle here, and right now the ramp is coinciding with line 1. So the slope of line 1 is same as slope of ramp. Now what we do is we drag this and put it here. Notice something? Yes, the slope of line 2 is also same as slope of ramp. So what can we conclude? The slope of two parallel lines is same. To verify this with more parallel lines, we can vary the pair of parallel lines. Let's just do this and you keep an eye on how the slopes comes out to be same every time. So this is another learning from this video. I hope you are noting down all the conclusions. If you are not, then don't worry. I'll do that at the end for you. Okay, last bit of beauty for you. I am changing the location of this point due to which line 1 will change. And since line 2 has to be perpendicular to line 1, it will also change. You need to see the slopes of two lines when these two lines change and try to find the relation between their slopes. Notice something? Not yet? Okay, I will tell you. Note that product of slopes of two lines is -1. So basically, the slope of line 2 is reciprocal and negative of slope of line 1. Can you think about why it is happening? I will give you a hint. See that to obtain the line 2, we have to do nothing but rotate line 1 at an angle of 90 degrees. So the rise, run, ramp triangle of line 1 also get rotated by 90 degrees. And hence in line 1 and line 2 the role of rise and run is reversed. Rise of line 1 is run of line 2. Got it? But where does that negative sign come from? I will leave that for you to think about. So this is it for the video. I hope you understood everything that I wanted to communicate through these animations. But even if there's something that you did not, then please ask in comments. As I promised earlier, Here is the list of conclusions or the learnings we had from this video. Note these down as I will be taking them for granted in future videos. Next video will most probably be on straight lines. Until then, stay tuned and keep learning.